In the rapidly evolving world of software development, Rust stands out as a language that champions safety, speed, and concurrency. One of the fundamental aspects of harnessing Rust's full potential is mastering its variable management. By understanding how Rust handles variables, you can write more efficient and reliable code, ultimately improving your programming productivity. As we delve into this tutorial, you'll see how variable mastery sets the groundwork for advanced Rust applications. Building on the foundation of Rust's significance, let's explore common pitfalls that beginners face when dealing with variables. One frequent issue is incorrect variable initialization, where forgetting to specify a type might lead to unexpected behavior. Additionally, misinterpreting data types can cause type mismatches, breaking your code. Improper scope management is another common error, as failing to maintain proper scope can lead to troubling bugs and undefined behaviors. Recognizing these mistakes early can save you time and effort in debugging. Having discussed common pitfalls in Rust variable usage, let's delve into how Rust handles variables differently. At its core, Rust enforces strict type safety, which ensures that variables are explicitly defined and type-checked, preventing common runtime errors. Moreover, Rust variables are immutable by default. This means once a variable is assigned, it cannot be changed, enhancing the reliability of your code. However, you can opt for mutability when necessary by declaring variables with the mut keyword. This default immutability encourages safer concurrency and reduces the risk of bugs, making your programs both efficient and robust. Now that we've covered Rust's strict type safety and immutability, let's see it in action with some code examples. We'll begin by declaring variables in Rust. Here, let x equals 5 creates an immutable variable. Attempting to change x later would result in a compile error. On the other hand, let mut y equals 10 defines a mutable variable, which we can modify as seen when y is updated to 15. Rust also allows you to specify data types explicitly, as with let z f64 equals 3.14. This approach ensures clarity and precision in your code. Building on our understanding of Rust's variable handling, let's examine some common pitfalls that programmers encounter. Firstly, improper management of variable scope can lead to unexpected errors, especially in complex applications. Understanding Rust's lifetimes is crucial, as they dictate how long references are valid, preventing dangling pointers. Lastly, neglecting Rust borrow checker can result in compile time errors due to conflicting access patterns. This powerful tool ensures memory safety by enforcing rules about how data can be borrowed and modified. In this comprehensive guide, we've explored the intricacies of variable management in Rust. You learned how to effectively declare and initialize both mutable and immutable variables, and understood the significance of Rust's strict type system. We also delved into avoiding common pitfalls such as mishandling lifetimes and utilizing the borrow checker for safe memory access. As you continue your Rust journey, remember to practice these concepts to reinforce your skills. If you have questions or insights, share them in the comments below. Don't forget to subscribe for more programming deep dives.